A boy slides down a straight grass bank inclined at 30 degrees with the horizontal. Horizontal, 30 degrees, bank. If the length of the bank was 5 meters, so that's the actual length of the bank. This is your bank over here, and that is 5 meters. What is the height of the bank? So the line that I'm interested in is how high is this bank over here. So if I label this triangle, I've got a 90 degree here, which means that this is opposite, adjacent, hypotenuse. And I'm able then to say I'm interested in the opposite, and I know the hypotenuse. So I can say sine of 30 degrees is equal to the opposite side, which I don't know, over the hypotenuse 5. Rearrange that, and the opposite side turns out to be 2,5 meters. The perpendicular components of a displacement vector are 8 meters west and 6 meters north. I don't have to draw to scale at all. Complete the parallelogram and put in a arrowhead like that, and I am able to get the resultant. The resultant squared is equal to 6 squared plus 8 squared, so R turns out to be 10 meters. And then I'm interested in an angle. Probably that little one's the easiest to find, and then just subtract it from 360. So I'm going to say, I know the opposite, and I know the adjacent, so tan of alpha is equal to the opposite side over the adjacent side, and alpha turns out to be 53 degrees. When I subtract 53 degrees from 360, I get my resultant is 10 meters at 307 degrees, and that means that I've come all the way around to 307. Two forces, one horizontal and the other one vertical, act on an object. The magnitude of the vertical force is 90 newtons, while the magnitude of the resultant of the two forces is 150. Find the horizontal force. So the first thing I'm going to do is I'm going to try and draw that up. We've got a vertical force of 90 newtons, and I have a resultant of 150. Remember, resultant is always the diagonal of the parallelogram, and therefore I'm interested in that particular force over there. I've got the hypotenuse, r squared is equal to opposite squared plus adjacent squared. So 150 squared is equal to 90 squared plus I don't know what squared. I'll call it the horizontal force. And when I rearrange that, the horizontal force comes out to be 120 newtons. A boy pulls a box across the floor by means of a rope, which makes an angle of 60 degrees with the horizontal. I draw a horizontal, 60 degrees. So the force he applies is 40 newtons. With what force is he tending to lift the box? And with what force is he tending to pull the box across the floor? So I'm working out the vertical and the horizontal components. If I complete this parallelogram over here, I've got 60 degrees. That is the equivalent of my vertical force. I've got a hypotenuse. This is opposite 60, adjacent, and hypotenuse. So I can say sine of 60 degrees is equal to the opposite, which I don't know, over 40. And that turns out to be 34,6 newtons that he tends to lift. That is the green line. If I'm looking for the adjacent, I'm going to say it's the adjacent side, so I use cos. Cos of 60 degrees is equal to my adjacent side over 40, and I land up with that being 20 newtons that he tends to pull across the floor. A bullet is fired with a velocity of 200 meters per second at an angle of 20 degrees to the horizontal. If they were to give you one to the vertical, it would just mean that you would come off from a north line. Calculate the magnitude of the horizontal and vertical components of this velocity. So I'm interested in the horizontal component and the vertical component. That's the actual vertical component, but the line across over here is equal to the vertical component, and we complete the parallelogram. Again, if I'm going to label this triangle, I'm going to land up with adjacent, opposite, hypotenuse, and I know the 20 degrees. So I will say the vertical component, firstly, sine of 20 degrees is equal to the opposite side, which I do not know, over the hypotenuse, 200, and I land up with the vertical component being 68,4 meters per second. The horizontal component, I'm going to say that's the adjacent side, so it's cos of 20 degrees is equal to the horizontal component over the hypotenuse, and my horizontal component turns out to be 188 meters per second.